So in this video, we're going to talk about sex-linked genes and how do you know if something's sex-linked or not? How do you predict their chances? So as you know, male is XY chromosome, female is XX chromosome. One of the chromosomes must have come from mom, one of the chromosomes must have come from dad. And so if you look at it, if a male has a child, what does the male have to contribute to the child in order to have a male child? So if we look at it, who is the only one that has a Y chromosome? Men. So it's actually the male sperm that decides whether the child is going to be a male or a female, because the male sperm can either have an X chromosome in it or the male sperm can have a Y chromosome in it. The female does not have a Y chromosome, so the female can only contribute X chromosomes. So sex-linked gene, it just means that this gene, instead of on the other chromosome, this gene is on the X chromosome or the Y chromosome. That's why it's called a sex-linked gene. So this, you can't do the normal Punnett square with like normal genes. You have to do the Punnett square with the gene attached to the X or Y chromosome when you calculate the predictions here. So let's do an example. Okay, so here if we see XR, lowercase r, that's going to mean that the gene is recessive and it's on the X chromosome. If you see a capital letter, it means it's dominant, and in this one it's also linked to the X chromosome. How do I show that it's linked to the Y chromosome? I would just do this. Right? And if it's linked to the Y chromosome, it doesn't matter whether I write dominant or recessive because there is no dominant or recessive for the a Y-linked gene. How come? Because as you can see, there's only one Y chromosome. There's no choice. A male has to use that Y chromosome. So there's no dominant or recessive when it comes to Y chromosome. But there is dominant and recessive when it comes to X chromosome because there's a choice. Only for the female though, right? For the male, if the trait is dominant, doesn't matter. The male will use it, right? If the trait is recessive, doesn't matter. The male will still use it, right? Okay, so let's look at this now. Let's say our trait is dominant, okay? We're going to pretend trait is dominant. What's the chance that the boy will have the trait? So you can see here's one example parent, female, male. We could do the Punnett square as normal. So I put the female on one side, and I put the male on the other side. And then I'm going to go ahead and do the Punnett square. So you notice every box has an X capital R in it. So I didn't even bother to write the other one. The boy and the girl will 100% have the trait in this situation because the mother is homozygous dominant, and the boy has to get the X chromosome from the mother. Let's look at another example though. Let's look at example number 4. So XR, XR, X capital R, Y. So we're going to go ahead and look at this example here. In this example, only 2 out of the 4 boxes is going to have the X capital R. But in this situation, normally we'd be like, oh, 50% of kids is going to have this condition, right? But in this situation, because it's sex-linked, we actually notice that all girls are going to have this trait because the girl has to get the X chromosome from the father. But none of the boys actually have this condition because the boys are not able to get the X chromosome from the father. The boys have to get the Y from the father. So actually all the boys don't have this condition. So you can see sex-linked genes, you can just use the Punnett square like normal. You just have to be mindful that you include the X and the Y chromosome because it does make a difference compared to normal Punnett square calculation. Okay, so and as you can still do as normal, where if you have chance of 2 things, like you want a chance of blue skin and you want a chance a blue skin boy with the trait, then you would just multiply your chance of blue skin with the chance of boy with trait. So you can just multiply probabilities like normal, right? Or let's say you want a blue skin boy with trait and he also have 4 arms, then you multiply the chance of each of those traits together. So that still happens like normal if you have more than one trait that you're looking at. For practice, we can also just go ahead and do number 2 as well. So what's the chance that the boy would have the trait in this situation? Well, the boy has to get the Y from dad, so we're going to ignore dad. And so he has a 50% chance of getting the trait here, right? Because the mom can give this X chromosome or the mom can give this one. And what's the chance that the girl would have the trait here? Well, the girl has to get the X from dad, but it's 50% from mom, right? So the chance of the girl having it would be 50% here, right? And we can even do the Punnett square for this, just to show you guys, right? So example 2. XR, XR. Right, so dad has to give the Y. And then this is X capital R, X capital R. And then this is X lowercase r, X lowercase r. This is X lowercase r, X lowercase r. So you can see 2 boxes. One out of the 2 boxes has the X capital R, so it's 50% chance of girl. And 2 out of the boy boxes have the X capital R, so it's 50% chance boy, like we just said.